Hi, my name is Aaron Sampson. Computers need software to function, and that software has changed fundamentally since the very first computers were created. Today, we use sophisticated operating systems, or OSs, to perform everyday tasks. In this course, I'll introduce computer operating systems, beginning with the types of OSs and the application hardware interface. Then I'll explore Windows management, application and device management, and user management and access control. Finally, I'll delve into file systems, key OS features, task scheduling, and common methods for tweaking a Windows operating system, including using command line interfaces or CLIs to perform operations. Upon completion, you'll have built the foundation for the basics of IT. This course helps to prepare learners for the CompTIA IT Fundamentals or ITF Plus certification exam FC0 U61. In this video, we'll outline the basic types and features of computer operating systems, or OSs, which is the software that permits interaction with the hardware of the computer itself. And more so from our perspective as users, it facilitates the execution of the software applications that we use on a daily basis. In short, without an operating system, you have little more than a collection of hardware parts. Toward that end, operating systems tend to be subdivided into two primary components, the kernel and the shell. The kernel is the core component in terms of acting as the interface between applications and the hardware itself. When an operating system is initially booted, the kernel is loaded into memory first, and it remains there until the computer is shut down. Once loaded, the kernel provides access to resources for the applications and services we use, but we as users have no direct access to the kernel. It's all managed and maintained internally by the operating system itself. The shell, however, does provide us with access to the operating system by prompting us for input, either directly through something like a command prompt or a script or even through an application. It might be somewhat transparent to us in our day-to-day use, but every time we launch an application, we are providing some kind of input through the shell because we're requesting that some kind of operation be performed. Operating systems come in various forms for the devices we use these days, and while they all perform the same basic function, they each have the specific implementations that are more appropriate to the type of device on which they're installed, including mobile devices, workstations or desktops, and servers. Again, the basic functionality of the operating system is the same, but it's the manner by which they allocate and manage resources that distinguishes one from another. Most notably, servers are not designed for use with standard line-of-business applications. In other words, users don't generally sit down at servers and check email or browse the internet. Servers are designed to do exactly as their name indicates, service requests. For example, when you view a web page, there is no browser or similar application that needs to be running on the server. It just has to deliver the files that make up the site to your computer. But it might also be delivering those files to thousands or even millions of other computers. So its resources are fine-tuned to supply what's often referred to as back-end services, which in this example is to just serve up files over and over again. But on a desktop, this is where we use applications, so we want our systems to run those applications as effectively as possible. So desktop operating systems are tuned for what is known as front-end operations. So while servers do tend to be very powerful systems, they would not be the best option with respect to running demanding front-end applications. So the priorities of desktops and servers are effectively the opposite of each other. Mobile OSs are similar in functionality to desktops, but they tend to be more stripped down, so to speak, to run only a specific type of application that we've generally come to refer to as apps, whereby the functionality of any given app has a more specific purpose, and they're usually less demanding than their desktop counterparts. In short, you generally don't see full line-of-business applications on mobile devices, but some of them are capable of doing so. It just depends on the make and model, but usually, if full-blown applications are needed, a desktop operating system would be the better choice. The more pared down version of a mobile OS also helps to increase the battery life, whereas that isn't a concern for something like a desktop computer. Common examples of mobile operating systems include Android, which is an open source OS of Google, meaning that it can be implemented by various manufacturers, including Samsung, Sony, LG, and many others, and iOS, which is proprietary to Apple, so it's only found on Apple devices. Common desktop operating systems include Microsoft Windows, Apple's Mac OS, Linux, which is also open source and available for free, and Google's Chrome OS. And in the server community, common operating systems include Windows Server, Linux servers, and Unix servers, and it should be mentioned that Linux is a derivative of Unix, but Unix is not a free OS, although different vendors are able to license out their specific implementations. FreeBSD is another Unix-like operating system, but as its name indicates, it is free. Novell NetWare, and Mac OS Server. Now, just a few quick points here. With respect to the free operating systems, you might think, why doesn't everyone just use those? Well, in short, you certainly can, but an open source operating system doesn't just mean that it's free to use, it also means that anyone can modify the code. In other words, they're not owned or managed by anyone, and they're developed by a community of developers. As such, they're typically designed with very specific services in mind, and there are far fewer applications available for them since they aren't standardized. But when you do need that more specific task, they can be a very good option, not only because they're free, but as a more focused implementation, so to speak. They generally run very reliably and offer very high security. In short, the less a system has to worry about, the better it can be at its intended job. Think of them much like specialists. Also, NetWare was a common operating system back in the late 1990s and early 2000s, but it is largely extinct today. There were a number of factors, but given that Windows is by far the most commonly implemented desktop operating system, at least in corporate environments, Windows servers offered much better interoperability than NetWare, so it really just got phased out. Other types of operating systems include what is known as the embedded OS, which is typically found in specialized devices that are dedicated to specific tasks. These tend not to be what you and I would think of as a computer, but something like banking machines, public kiosks, industrial or manufacturing control systems, and many other devices would have embedded OSs. And firmware is similar in that it's a specific operating system for a specific type of device, but usually for smaller, more portable devices such as fitness monitors, GPSs, printers, or routers. Lastly, one other type of operating system is what's known as the Type 1 hypervisor. And there is a Type 2, but I'll come back to that in a moment. These are also referred to as bare metal hypervisors because they can be installed directly onto hardware, just like a standard operating system. But they're very lightweight and can still provide the ability to interact directly with hardware. But the reason they can be so lightweight is because they're essentially designed to be translators, so to speak, for other operating systems, or what we commonly refer to as virtual machines. In a traditional configuration, if you install a standard operating system onto your hardware, that's it. That's the only instance of an operating system that can be supported, at least at one time. In other words, you can install more than one OS onto a computer, but you can only boot into one of them at any given time. With a hypervisor, however, once it's installed, you can then create multiple instances of virtual machines which can all run at the same time. Each instance has the more standard OS installed, but its requests to access hardware are intercepted by the hypervisor and executed by the hypervisor. But as far as the virtual machine is concerned, it's not even really aware of the hypervisor. It makes its standard calls to hardware, and those calls are processed. So again, multiple virtual machines can all run at the same time. The hypervisor simply satisfies the requests of all instances. Now, coming back to the Type 2 hypervisor, It performs the same task in that it allows you to create and run virtual machines, but a Type 2 hypervisor requires the presence of a standard operating system first. The most commonly used example of a Type 1 hypervisor is VMware's ESXi, and the most common example of a Type 2 is Microsoft's Hyper-V. But again, in order to run Hyper-V, you have to install Windows Server first, then add Hyper-V support as a role. ESXi is installed directly onto the hardware. Ultimately, in order for any computer or other type of computing device to do anything, an operating system must be installed. But of course, the OS that will best suit your needs will depend on the circumstances, so be sure to familiarize yourself with the characteristics of each before making that decision. In this video, we'll examine the interface between applications and hardware, which provides us as users with the means to interact with the hardware of our devices. Now, in general terms, we can rightly think of that interface as being the operating system, because that is ultimately what we use. But there's more to the process than just having an operating system installed, most notably because any given operating system is usually capable of being installed on any given collection of hardware, and of course, it still has to work. For example, I'm running Windows 10 as my operating system, but it's running on a proprietary laptop. But of course, Windows 10 can run on many different proprietary laptops and many different desktops, all with different hardware. And of course, the same applies to many other operating systems as well. So the interface between the application and the hardware is what allows the same type of operating system to be supported across many different hardware configurations, while still providing us as users with the ability to use those systems in a consistent manner. One of the key components involved with that process is known as the hardware abstraction layer, or HAL. The HAL itself is an additional layer of programming between the operating system and the hardware that quite literally abstracts the hardware so that the operating system can interact with it in a more independent and generalized manner, as opposed to at a very detailed and perhaps custom level that is specific to that piece of hardware. This approach primarily allows for manufacturers to create devices that don't need to be constructed differently for different operating systems. Or more to the point, the same device can be used in different operating systems by simply creating drivers or sets of software instructions that are appropriate to the operating system into which that device is being installed. For example, if I'm a manufacturer of printers, I don't want to have to create one physical model for a Windows device and an entirely separate physical device for Macs. I just create one physical device, then supply a driver for each operating system. The hardware abstraction layer, in this example, means that the operating system need only make a call to the device in the manner or format specified by the driver. This approach of using an interface also shields us as users from low-level hardware activities, meaning that the applications we use have no direct access to hardware. Calls are made from the application, such as when we click on the print button, but that call is then intercepted and processed by the operating system and its associated drivers, so that applications can't interfere with each other in terms of requesting access to any type of hardware. The interface manages all interactions, and the applications simply wait for the responses to their requests, which in turn means that they can share input-output between all applications that are running, which in simpler terms means that we can run multiple applications at the same time, or what is known as multitasking. And for as mundane as that might sound these days, in fact, in the early days of computing, this was not the case. Prior to interface implementations such as these, you could only run one program at a time. When you were finished with that application, you had to close it out entirely and then load the next one. Now, it's also worth mentioning that the use of interfaces does not only include hardware. An application programming interface, or API, is a software component that allows for applications to be integrated more easily onto an existing system, because the same API can provide functionality to new applications. This can greatly increase the speed of developing those applications because new code does not have to be written from scratch for each new application. So an API can be thought of as a bit of a platform, if you will, upon which many applications can run. Ultimately, the use of interfaces has greatly increased the functionality, flexibility, and compatibility of our computing devices, and without them, almost every piece of hardware and every application for every type of device would have to be uniquely coded for that specific configuration, which would greatly hinder both the speed at which new devices and applications could be created and the level of innovation that they could achieve. In this video, we'll take a look at some basic ways to manage the Windows environment, including disks and process management, which in itself includes task management and memory management, and some of the ways by which the processes that are running on your system can be configured with respect to how they interact with the CPU. Now, with respect to accessing these interfaces, both of them can be accessed in Windows 11 by right-clicking directly on the Start button, and in the context menu that appears, you'll find Disk Management and Task Manager. So again, I have both running already. So we'll begin in Disk Management, and this is the utility that is used to configure your internal storage. Now, if you have just gone out and purchased a new system that is already running Windows, then you likely will not have to do anything in the Disk Management utility until such time as you decide to install an additional hard drive, for example. So that is more or less what I have here. This Disk 2 down here would represent a new hard drive that has never been used. So it actually says in here that it is unallocated. So one of the primary tasks is to configure what's known as a volume. Now, you might have heard the term partition as well, and they largely mean the same thing in that they are a section of the disk that can be used to store data. And any given disk does not have to use 100% of its available space for any given volume. In other words, I could take this unallocated space and I could create more than one volume, which would keep the drive letters separate, so that if, for example, I wanted to keep work files separate from personal files, I could do that. Now, you certainly can use all of the available space. It's entirely up to you. But with respect to creating a volume, you can just right-click in the unallocated space here and choose New Simple Volume. It launches a wizard that we can go through, and really you just have to provide the answers. So let's just click on Next. And here's the primary value that you specify, the size of the volume. So it is going to default to use 100% of all available space. And again, that's perfectly fine. But just for the sake of argument, I'll go with something around 50% of all available space. So this is giving me the size in megabytes. So 100,000 megabytes in this case is 100 gigabytes. So I'll go with 50,000. And just click on Next, and that's approximately half of the space. Then it wants us to assign a letter. You can really choose any available letter, and it's defaulting to E because there are already other drives on that system, so that's perfectly fine, and we'll just click on Next again. And formatting is what applies the file system. Now, with a Windows system, NTFS, or the New Technology File System, is almost always what you're going to apply to an internal hard drive, so we'll leave that at its default, and we'll leave the allocation unit size at its default as well. But just for the sake of knowing it, that's the smallest amount of space that can be used when writing files to a disk. So they typically are quite small. In fact, if we hit the drop down here, they're only measured in bytes. So if, for example, I were to choose something like 4096, that's 4 kilobytes. So that's the minimum amount of space that any file could occupy, even if it isn't that large. Now, again, we don't really need to worry about that too much. We can just leave this at its default. But the volume label is something that you can apply so it has a more meaningful name. So by default, it's just saying new volume. Let's just go with something like data drive. And the quick format option will simply apply what's known as the directory entry table, which can more or less be thought of as a table of contents. It does not go through every single sector of the hard drive, so this does exactly as its name indicates, and it makes the drive ready to be used much more quickly. So we'll just click on next here and finish, and basically that's it. I'm going to see my volume appear, and we do see that it is approximately 50% of the available space, so that unallocated space is still available to be used if I wanted to create another volume. And by leaving that space available, if I discover that I need more space on the volume that I just created, I can right-click, and there is an option to extend the volume. So as long as there's available space, I can actually make use of it. And you can also do the opposite and even shrink the volume if you need to reclaim some space. So again, that's the primary task with respect to disk management, just creating a volume that can be used. So let's minimize here and we'll switch over to the task manager. Now, with respect to what you'll see in here on this first tab, the processes page shows you all of the applications that you have launched as a user, along with background processes, and if we scroll all the way to the bottom, you'll also see Windows processes. So those, of course, are fairly internal processes that you generally don't have to work with all that much, but they all, of course, consume system resources. So what we see are the CPU values, the memory values, the disk usage, and the network usage. And basically, this gives you an idea as to how busy your system is. Now, for any application that you have launched, you can see how demanding it is by just examining the CPU value and or the memory values, but you can also go to the Performance tab to see an overall picture of how busy your system is in terms of the CPU and the memory. Now, there's not much that you can do in terms of memory management here other than keep an eye on it to see what kind of values you are getting out of your system. And basically what you want to see is enough memory available to be able to launch extra programs and do more work. So if you start to see your memory consistently at or approaching, let's say 90 or 95%, then basically that's indicative of your system not having enough memory. And the more applications you launch, the more memory will be required. So if, for example, we just go down to our taskbar here, and let's launch something like Microsoft Edge, we will see in the task manager that the memory usage is going to increase, as is the CPU usage, so we can switch to the CPU here. And it's certainly fine to see a large increase like this when an application loads, but what you don't want to see is it staying up there. You want to see it spike or peak, but then you also want to see it come back down to a more normal level once the application has loaded. Similarly, once we close down these applications, we want to see the memory get returned to the system ultimately. So we can get a picture as to what's happening here, but if we look at the individual processes, this gives you a better idea as to how demanding any given application is. And what you can also do is to see how it's interacting with the processor in terms of its percentage of time. Now, there's even more information that you can ascertain from this, because if you right-click on any process that is running, you can choose to go to the details, which brings you to the details tab at the top here. So you can just go to the details tab at any point in time, but this brings you to the specific executable for that particular process. So I'm just using the Task Manager application itself here. But for any application, you can find out the exact same information, and it tells us exactly how much memory is being used by that particular executable, and you can see how much processor time effectively is being used by that particular process. Now, that value is going to change as you perform certain tasks within any given application. Again, while you're using something, you want to see it get busy. You want to see the processor pay attention to that process, but as you move away to a different application, you want to see it settle down, for lack of a better word. But one other thing that you can do with your processes is to change how they interact with the processor, as mentioned earlier. And this is essentially what's known as scheduling. Now, it's not something that we can schedule like you set an alarm, for example, but the processor has to manage all of these processes, but it can really only deal with a certain number of processes at any given time. In other words, in multitasking, certain processes are processed for a certain amount of time, then it moves on to another process whenever needed. So it switches back and forth, so to speak. So what you can do if you have a very critical process is to allocate more processor time, or increase its importance, if you will, in terms of the scheduler, which, by the way, is internal to the operating system. We don't ever see it, but it allocates more time to that particular process. So I can right-click on this executable, and there's an option here that says Set Priority. And here there are several options, including real-time, high, above normal, normal, below normal, and low. So again, this tells the scheduler that this particular process should receive more processing time if you change its value. Now, I don't need to bother changing anything at this point, but those options are available if you have a particular task that is very demanding or mission critical. So again, remember, in terms of getting to that specific process, you can go to the Processes tab, find the application itself, then right-click on any one of them, and then choose Go to Details. It will then go to the specific executable for that particular task. Now, just quickly, if I go back to the Processes tab, if I right-click on something like Microsoft Edge, notice that there is no option to go to the details. That's because there are 8 separate processes running here. So if I expand it and then select any individual process, then I can go to the details and it will show me that specific executable. Once again, I can see the memory values, how much CPU time is being taken up by that executable, and if necessary, alter its processor scheduling characteristics. Now, for the most part, those operations are not particularly common on desktop systems just using day-to-day applications, but depending on what your system is being used for, then they certainly might be required. In this demonstration, we'll take a look at some basic device and application management steps in Windows. And I do want to stress that this will be rather basic because application and device management can be quite involved. Now, I have 2 interfaces open here, and one is actually called the Device Manager. So we'll begin in here. And this is quite simply where you can centralize the management of all devices that are attached or installed in your computer. And they're broken down by various categories. So if, for example, you do need to configure something like your display adapter, you can expand it in here and you can work with that device. Similarly, you can work with your network adapters, your mice and keyboards, or other human interface devices, or just about anything that is available in here. And perhaps the most common task associated with working with devices is updating the driver. Now, in many cases, this might happen automatically through the process of Windows updates. But if you discover that there is a new device driver for any given device at any point in time, you can absolutely update that driver at any time. So as an example, if I just go to my network adapters and I click on either one of them here, what you'll find is a driver tab. And in here, you will find an option to update the driver. Now, this does suggest that you have already obtained the driver. Either you have it on a physical disk or storage device of some type, or you downloaded it directly to your computer. It doesn't matter where it is as long as you have it. So I can just click the Update Driver button, and I can choose to browse my computer and supply the location of that driver. Then, if for any reason that update caused any kind of a problem or didn't even succeed at all, what you'll notice is that there is a rollback driver option in here as well. Now, it's not available for me because I haven't updated my driver, but if I had and a problem appeared, then the rollback option becomes available, and that quite literally does exactly as it sounds. It will discard the new driver that you just installed, and it will revert back to the original one as if nothing happened. You can also view the current driver details by clicking that driver details button, and it will show you exactly which files are being used as the driver for this particular device. And you can get an idea as to the file version here as well. So you can click on either one and it will give you a version number, which can help you to determine if there is a newer version available. And again, if the device is being particularly problematic, you can disable the device entirely or even uninstall it. So those are some of the basic device management steps that you can do. Now, you might also want to add a device, which you can do through the device manager here. But in general, what you do is to install the software and or the driver, then physically install the device or attach it, and Windows should pick it up automatically through the plug and play process. But if for any reason that does not seem to be invoked, if you go to the Action menu here, you can choose to scan for hardware changes. Now, if that fails, you can still manually add a driver, and this will prompt you for the location of the new driver. Then again, you specify where it is, and Plug and Play should detect it once you physically add the device itself. Now, in terms of adding, you can also do that through the Settings app. So let's just close the Device Manager here. And if we go to the Bluetooth and Devices node of the Settings app, and I should point out that this is in Windows 11, then you do see several types of devices listed here, such as printers and scanners, cameras, mice, pen and Windows ink, and various USB devices. But there is an option here to add a device. And typically this is for something that is Bluetooth or wireless, but if we just click on the button here, it gives us a few choices, and it does say Bluetooth, wireless, or a dock, then everything else. But basically you just choose the type of device, and Windows will do its best to walk you through the process of installing that device. If the installation succeeds, then you should see it appear in your devices list here and in the Device Manager application. Then you can click on any one of these categories to access that type of device, and it will simply show you what is currently installed, or you can add a device for that particular category. So since I just clicked on printers and scanners, now I have the option to add a printer or a scanner. Okay, so there are plenty of device options available in here. And with respect to applications, over on the left-hand side of the Settings app, we can choose Apps. And if you want to see some of the configuration of your existing apps, the very first option that says Apps and Features shows you the installed apps and some of their characteristics. So we can scroll down through the list here, and we can see which apps are installed. It tells us a total number, and it tells us how much disk space is being occupied by that application. And if we click on the little three dots or the ellipses next to that entry, we can modify the installation or we can uninstall it if we choose to. Another common application management task is determining which application should be used by default for which type of file. So if we go back to the primary apps node, which we can do by just clicking the word apps here, you'll see this option that says default apps. So we can click on that, and this will show you the current default applications for certain types of files. So the first entry here of Adobe Acrobat is a good example. I can click on this, and it tells me that it is going to be used for all of these different types of files. Most notably PDF. That's one of the most common file types in use with Adobe Acrobat. But it's not the only application that can be used to open PDF files. So if I click here, it gives me an option to choose other applications. And there's even a More Apps option here if I want to see more choices. But I can essentially decide which application should be used by default to access that type of file. So again, that's up to you, and it certainly will depend on what you have installed, but a lot of file types are very compatible across many different types of applications. So as mentioned, it's up to you to decide, but as long as you do have compatible applications, then you can change the default app to whichever one you prefer. So again, there are certainly more detailed tasks that can be done with respect to both devices and apps, but those are some of the basic tasks, and once you have them configured and set, for the most part, you won't need to make changes very often, but it's good to know where you can make changes when necessary. In this video, we'll provide an overview of the basic activities involved with user management and access control, which is a process that can be performed both at the individual or the group level to establish permissions to resources and to monitor their usage to ensure that those resources are being accessed in an appropriate manner. Now, for the sake of simplicity, we'll stick with a networked environment here, although it certainly isn't out of the question that you might implement these same measures at home. If, for example, you have a single family computer that is used by many members of the family, but it's much more common in corporate networks. So the process begins with assigning a user account and password to each user, which they can use to identify themselves to provide authentication. And if you're working in a corporate network environment right now, then it's quite likely that you did this when you showed up at your computer. You enter your username and password, which is verified by a server or some other type of authentication device or service, which then ultimately determines which resources you're able to access and which activities you're able to perform. Now, as mentioned, user management can and is performed at the individual level, but it's worth mentioning that it's much more common to implement permissions and abilities at the group level, at least in networked environments, because many users will often have the same needs. For example, all people in the same department would likely need access to the same files. So by grouping users by some sort of shared attribute, such as department or clearance level, you can assign permissions just once to the group, and all group members receive the exact same permissions. Otherwise, you would have to assign that same set of permissions many times, once for each user. The permissions and/or privileges being assigned typically define your access level, which is usually in the form of an allow versus a deny entry. The allow entry clearly grants you the ability to access a resource or perform a task, while the deny entry explicitly prevents that activity. Now, I should also point out that you don't have to explicitly deny users from accessing a resource if you want to keep them out. For example, if you supported 100 users and only 5 of them should have access to a confidential document, you don't want to have to explicitly deny the 95 others or even have to create a group that is then denied. You just don't give them any permission in the first place. In other words, if I don't explicitly allow you access to a resource, a deny is assumed. But if it's assumed, why bother having to ever use it explicitly? Well, it comes down to the practice of using groups. For example, you may have just hired a new salesperson, and it's common in many environments for new hires to go through a probation period. But the new employee is still a salesperson and would therefore need access to most of the same documents as all other salespeople. So it makes sense to add that person to the sales group. But by doing so, they would have the exact same access level as every other salesperson. So if there are some documents that only non-probationary employees should be able to access, then you can still leave the new employee in the group, but you can explicitly deny them access to those documents, and the explicit deny will override the permissions they have as a member of the group. So it's primarily used as an override, because all explicit deny entries will override any allow entries. In addition, because a user is a more specific entity than a group, entries that are applied directly to their user account will override entries applied to the group. So the deny entry in this example can be used to prevent access to those specific documents until their probation period ends. So the management of those permissions and abilities is what's known as access control, which is a key management task with respect to the security of any organization. Access control is solely concerned with determining who is authorized to access which resources or perform which tasks. And it doesn't only include documents, as we just discussed. It can also include physical access to certain rooms, such as the server room or the power supply room. And it can dictate certain abilities, such as which users are able to create other user accounts. But in order for any entity to be authorized to perform any kind of task, that entity must first be identified, which comes back to a point of the previous slide, which is authentication. Now, you might hear authentication and authorization used somewhat interchangeably in day-to-day conversation, but they aren't the same thing. In this context, authentication is always the process of establishing your identity, which we do most commonly by entering a username and password. On the assumption that we're the only ones who know our passwords, we are believed by the authenticating system to be who we claim to be. Once your identity is established, your ability to perform certain tasks then comes down to authorization. In other words, now that I know who you are, I can determine what you're allowed to do. Or to put that another way, if I don't know who you are, then I can't determine what you're allowed to do. So you can never be authorized until you are authenticated. Now, there are several models by which access control is implemented, and the particular model in use in your environment will depend on the circumstances and the nature of your organization. But common examples include discretionary access control, mandatory access control, role-based access control, and attribute access control. Discretionary typically refers to the fact that resources in any given environment have owners. For example, if you create a file, you own that file. As such, granting access to other users is done at your discretion. But in a networked environment, there are almost always network administrators who might control more centralized resources. So your level of access as a user might also be at their discretion. But again, it will depend on the nature of the organization. Other examples might be department heads or managers in terms of who decides which levels of access will be granted to whom. Mandatory is based on a level of clearance or a tier of your organization. This is typically implemented in governmental departments or the military, so that your level of resource access is determined entirely by your position or rank. Role-based is similar to mandatory, but rather than position or rank, access is determined by job functionality. For example, if your job title is support desk technician, then you would have access according to the needs of the support department. And attribute-based would be similar still to role-based, but it often includes additional factors such as location or region. For example, the support role just mentioned might have different needs if there are separate support divisions, such as HQ support versus branch office support. Now, to finish up, some concepts that are related to access control models include resource ownership, which we touched on when we talked about the discretionary access control model. And again, this refers to the fact that any given object typically has an owner. Now, in the case of documents, this means that whoever creates it owns it. But ownership and discretionary access is not limited to just files. For example, your organization might have a vehicle that can only be used by specific personnel, or a projector that must be reserved and signed out. So again, the ability to access those resources will likely depend on the discretion of others. Inheritance is also a factor in terms of resource access, which refers to the fact that when you do create something like a file, it has to be created in a folder. Even if you create it on the root of a hard drive, that is still considered to be the root folder or root directory. And as such, whatever permissions have been placed on the parent folder will inherit down to the files inside. Now, you can change the permission at the file level if necessary, effectively overriding the inherited permissions, but permissions are almost always inherited by default at the time of creation, so it's something to be mindful of when managing resource access. This is also not limited to just files. Many environments will use policies to determine certain abilities in a networked environment, which can be assigned to various organizational units, which are objects that can be created to contain user and computer accounts. And any organizational unit can contain other organizational units. So any policy applied to the parent unit will by default inherit down to the child units. And finally, Auditing refers to the process by which you can keep an eye on things, so to speak. When resource access control measures have been implemented, successful and failed access attempts are recorded in log files so that they can be reviewed to ensure that those who have permission are able to access their resources and those who don't aren't. In most environments, user management and access control is one of the most important activities of network and security administrators, as improper access control could lead to serious breaches of security and pose significant risk to the organization. So be sure to familiarize yourself with all methods of access control if you're considering a career in a security-related position. In this presentation, we'll examine various types of file systems, which provide a method for data storage devices to retain and locate their data with respect to the operating system on which those devices are being used. Now, as a very simple example, imagine an actual file cabinet. Rather than just piling every document into the cabinet with no organizational structure, you can label the drawers, perhaps alphabetically or by topic. Then within each drawer, you can place hangers that are color-coded, and within each hanger, you can place folders that are also labeled. By implementing that type of system, you know exactly where to place a new document when it's created, and you know exactly where to find existing documents. So the same basic concept is used with hard drives and other storage devices. Files are broken down into chunks, often referred to as clusters or allocation units, and each chunk is written to a specific location on the device, which is then recorded so that the file, in all of its chunks, can be efficiently retrieved when needed. So, just like the well-organized file cabinet of my example, file systems provide logical management of data and a more efficient means of accessing the physical media so that your computer doesn't have to search the entire disk every time it needs to locate any given file. The file system tells the computer exactly where to look. And just like the file cabinet, the method of organization typically depends on attributes, such as filing everything in alphabetical order or by topic. Similarly, files on a storage device also have attributes beyond just the data itself, often referred to as metadata. Common metadata values include the author, the creation date and when it was last modified, the size of the file, the last time it was accessed even if it wasn't modified, the last time it was backed up, the permission entries that have been applied, a version number if applicable, and a revision counter which tracks how many times the file has been changed. The file systems that you use will depend on the operating system of your computer, but common systems for Windows include the File Allocation Table, or FAT, FAT32, which is just a newer version of FAT. One of the original releases was a 16-bit version. exFAT, which is Extended FAT, and NTFS, which we'll take a closer look at in just a moment, but it's worth stating at this point that NTFS is overwhelmingly the most common file system in use with Windows. Linux supports the Extended File System, or EXT, versions 2, 3, and 4, the Journaled File System, XFS, which was implemented as a high-performance version of JFS, where X was originally intended to be filled in later, but never was, and BTRFS, frequently referred to as Better File System, which was implemented to address the shortcomings of other Linux-based systems. And Mac supports the Hierarchical File System, or HFS, HFS Plus as the successor to HFS, and the Apple File System, or APFS. So, taking a closer look at some of the more commonly used systems, the File Allocation Table, or FAT, was used as far back as Microsoft DOS, which stands for Disk Operating System, and at the risk of dating myself, was still commonly used when I began my career in IT over 30 years ago. It was certainly fine for the systems at the time, but as early as Windows 95, its limitations were becoming clear. Now, there are some variables that could affect the characteristics of any given implementation, but in general, FAT could support a maximum partition size of only 4 gigabytes, and on a Windows system, file names could only have 8 characters for the name and a 3-letter extension, so it was referred to as 8.3 naming. So with Windows 95, support for FAT32 was introduced, which initially could support a 32 gigabyte partition, which was later extended to 16 terabytes. Plus, file names could now contain up to 255 characters in total. Now, while those are tremendous improvements over its predecessor, the primary issue with both FAT and FAT32 is that there is no inherent security in either file system. In other words, permissions cannot be assigned, which is the single most important factor behind the introduction of the New Technology File System, or NTFS. As mentioned, NTFS is now overwhelmingly the most commonly used file system with Windows, and in fact has been the default file system ever since Windows 2000. It supports a maximum partition size of up to 16 exabytes, significantly beyond the capabilities of FAT32, but as stated, more importantly, it introduced the ability to set permissions on files and folders. NTFS would be found on virtually every Windows device these days, to the point where the only time you might still see FAT32 is with devices such as flash drives, which might be used on other computers, because FAT32 can be made to be compatible with other operating systems such as Mac, although you may have to install services so that each system can read the other's inherent file system, but they typically can't write to them. The extended file system was the initial system created specifically for Linux, and version 4 is the current version at the time of this recording. It supports a maximum partition size of 1 exabyte and a maximum single file size of 16 terabytes. Version 4 also maintains backward compatibility with both versions 2 and 3, so if files are transferred from a disk running those earlier versions, they'll be supported. Lastly, the hierarchical file system is the primary system in use with hard disks in Mac computers, but like FAT, its original release was not capable of supporting the larger disks of today, so its successor, the Plus version, supports a maximum partition size of 8 exabytes and a file size limited only by the partition size. In other words, a single file could occupy the entire hard drive. In short, the file system you're likely to encounter will depend on the operating system being used, and if you're installing a new operating system from scratch, you'll almost certainly be presented with the appropriate default file system to use, but others might be available as options. But you should almost always go with the default file system presented, unless you have a specific need to do otherwise. In this video, we'll take a look at some key operating system features that can help to manage your files and other aspects of your device, including compression, encryption, permissions, journaling, naming rules, and some limitations to consider. So, beginning with file compression, this is a method for literally reducing the amount of disk space required to store any given file, which is typically accomplished by replacing repetitive data with some kind of unique identifier. Now, to visualize that, think about something like a novel or a textbook, and imagine how many times the word "the" appears. For every instance, 3 characters are required. But if you were to replace every instance with a symbol such as an asterisk, then you would only need 1 character, saving you 2 characters each time, and your file becomes smaller. All you need to do is to maintain some kind of a key or a legend that indicates that the asterisk represents the word "the." Now, that's just a simplistic example, of course, but the process is essentially the same. Now, there are many applications that can compress files on your disk, each of which will produce a different file type, but common examples include zip, RAR or RAR, 7Z, which is also often referenced as 7-zip, which is the name of one of the applications, gzip, and TAR or TAR, and the AR in both RAR and TAR typically stands for archive. Now, those applications will allow you to start with just about any file or even multiple files, and then add them into a single compressed file, which basically acts like a container, making all files smaller and therefore easier to email or otherwise transport, and many will allow you to specify the degree to which they're compressed. Other file types, however, are inherently compressed due to the amount of data they contain, including JPEGs, MPEGs, and MP3s. Now, those are all multimedia files, and they'd simply be very large if they weren't compressed. So our computers decompress them on the fly, so to speak, meaning that we don't need a specific application to decompress them first, then access the contents. Now, as mentioned, the applications just listed are separate from your operating system, so they have to be obtained and installed separately. But some file systems, such as NTFS, have built-in compression. Now, while this does compress files on your disk, the compression is only present while those files are on the disk. In other words, if you're looking to compress a file so that it can be emailed more easily, then NTFS encryption is not capable of doing that. It's only for what's referred to as data at rest. In addition, NTFS compression is simply an on-off attribute of the file. In other words, there is no interface and no option to adjust the level of compression. You simply right-click on the file and enable compression in the Advanced Property window. You can also compress a folder, but this simply means that any and all files placed into that folder will automatically be compressed. Now, as far as enabling NTFS compression is concerned, for something like your internal hard drive, you should consider the space savings versus the performance hit, because compression does require extra processing in memory. But for any single file, that hit would be negligible, but these days, since hard drives and solid-state drives have become so large, running out of space is far less of an issue these days than it was, say, 15 or 20 years ago. But it might still be required if, for example, you're trying to fit a certain amount of data onto a smaller device, such as a flash drive, perhaps for archiving purposes. But if it is just being archived, then usually any performance hit is not an issue, because as an archive, it generally means that the data is not accessed very often. Encryption is a method of protecting data on disk by using advanced algorithms to scramble the data, which then requires a unique key to unscramble it. Just like compression, there are various methods by which data can be encrypted, and various levels, or what's known as cipher strengths, depending on your needs. And like compression, there are file systems that inherently support encryption, including NTFS, which includes a built-in component called EFS, which is the encrypting file system, ext4 in Linux kernel 4.1 and higher, and Apple's APFS with Mac OS High Sierra and above all support encryption as well. But also, like using built-in compression, using the inherent file system to apply encryption only protects that data at rest. As soon as the file is removed from the disk, for example, if you email a copy to someone else, the encryption is removed. But there are other separate applications and processes that can also protect data in transit, but they aren't built into the file system. So this type of encryption would be used to protect your data if, for example, your laptop was lost or stolen. Even if someone were to take the hard drive entirely out of that system and install it into their own system, they would not be able to access the encrypted data. Journaling file systems are used in situations where the ability to recover data in the event of failure is a primary concern, because as their name indicates, journaling tracks changes to data in log files, which can then be used to aid with the recovery of any lost data. And this can be a concern due to the fact that while you're working on any given file, the changes that you make are only made in memory, and they aren't written to disk until you save the file. So if your computer loses power before you save that file, those changes can be lost because memory is cleared every time the computer reboots. Now, that said, these days many applications have implemented autosave features, but if they only invoke an autosave, let's say every 10 minutes, then you could still lose up to 10 minutes worth of work. And some applications don't have autosave features at all. But since the journaling file system tracks changes as they occur, if power is lost, the original file plus the data in the log file can be used to restore your changes. Now, this approach does require some extra processing, but the trade-off is the increased reliability. So when the possibility of losing data just isn't acceptable, a journaling file system can be a good option. File naming standards are dependent on the operating system you're running, as well as the file system that is used on your primary storage device. And most naming conventions are distinguishable by the path or the directory structure, the number of characters in the name, including all folders and subfolders, and the extension, which indicates the type of file or the application that can be used to access it. Now, going back many years, this was a fairly limiting factor. For example, on early Windows computers, file names could only contain a maximum of 8 characters, then a period, then a 3-letter extension. So file names almost always had to be abbreviated. But ever since Windows 95, the entire file name, including all folders in its storage path, can now include up to 255 characters, so those limitations have been almost entirely removed. Other file system limitations, however, include restricted or reserved system characters such as backslashes and forward slashes, which are used as directory separators in almost all operating systems. Question marks, greater than and less than symbols, colons, double quotes, and several others are typically not allowed in a file name. And there are also several reserved extensions that can't be used, including .exe and .com, both of which indicate file types that can be executed as applications. So if you were to create a standard document called Plan of Execution, you might be inclined to use .exe as the extension, but after doing so, you would not be able to open it because your system would think that the file is a program of some kind. Periods in file names are supported by some file systems, but it can lead to some confusion because there is always a period between the name and the extension, and periods are typically not supported at the end of a folder name, but they are at the start or in the middle. I tend to recommend, however, that you just avoid using them entirely, and when it comes to most file systems and even the entire operating systems, it's important to note that they're largely incompatible with each other. Now, that said, that doesn't mean that they can't interoperate or that you can't share files with devices that are running other platforms. For example, if you're using a Mac and I'm using a Windows PC, you can email me a file that you created as long as I have a compatible application that can open that file. But if, for example, I were to take the hard drive out of a Mac and install it into my Windows system, it would likely not be recognized at all unless I were to wipe it entirely and reformat it. That said, there are services that can be installed that can provide read capabilities for other file systems, but usually not write capabilities. And when it comes to software applications, you almost always have to install a version that is appropriate to your operating system. For example, an application like Microsoft Word will of course install on a Windows PC, but you have to obtain the specific version for Mac to install it on the Mac OS. And finally, case sensitivity usually isn't a concern for file systems and file names, but it shouldn't be assumed. For instance, some Unix-based file systems do treat upper and lowercase characters as different from each other when it comes to file naming. In general, though, operating systems can provide us with many features by default, and new features are constantly being introduced, so it's a good idea to verify that your systems are receiving regular updates to ensure the highest level of functionality and feature support. In this demonstration, we'll take a look at using file and folder compression and encryption. Now, these features are available on other operating systems and when using other file systems, but for the purposes of this demonstration, we'll use the inherent compression and encryption of the NTFS file system on a Windows computer. Now, both of these can be implemented on either a file or a folder, so it doesn't really matter, the process is the same, but if you enable compression and/or encryption at the folder level, then all files placed into those folders will automatically become compressed or encrypted. But again, you can apply these attributes to just any given file if you want to. So what I've done is to simply create two folders, one called compressed and one called encrypted. And both of them are empty. I haven't done anything with either one. They're just folders at the moment. But I'll use each one to show how you can enable the attribute. So for the compressed folder, we'll just right click and choose properties. And in the very first page, you'll see that there are attributes and an advanced button down in the lower right-hand corner. Both compression and encryption are considered to simply be attributes of the file or folder. So if we click on advanced, there are two options in here: compress the contents to save space, or encrypt the contents to secure the data. And both of them are simply on-off values. But do take note that you cannot enable both on the same object. So if I select compress, it deselects encrypt. And likewise, if I select encrypt, it deselects compressed. Okay, so in this case, since it's the compressed folder, this is all I have to do. Enable that checkbox, click on OK, and click on OK again. That's it. Now, as soon as I create a file or drag and drop a file into that folder, it will become compressed. So I can just simply go to the folder now, and if I just right click and choose something like new text document, I'll just type in anything here, hello world, and save that file. It is now a compressed file. Now, I didn't put anything in the document, but basically everything that ends up in this folder will now be compressed. Now, if you want to, there is a folder option that can help you to more easily identify compressed and or encrypted files and folders. So if we go to the ellipses where it says See More at the top of the window, I can choose Options, and in here on the View tab, there is an advanced setting that displays encrypted and or compressed files in color. So there's the option right there, show encrypted or compressed NTFS files in color. If I select that and click on OK, now we do see that the compressed files show up in blue, as will the folder. Okay, that's it. That's all there is to compression. And if I had an existing file somewhere, if I were to just drag and drop it into that folder, again, it would automatically become compressed. If you do want to implement it at just the file level, then you can absolutely go about it in the exact same way. Just right-click on the file itself, go to Properties, go to the Advanced option, and simply enable the compression checkbox. But in my case, notice that it is on because I created this file in a compressed folder. Okay, but you can do it at just the file level for any file in any folder if you prefer. Now, as for the encryption option, it's the exact same process. So we'll go to the encrypted folder, we'll right-click, and we'll choose Properties, then go to the Advanced option here, and simply enable the option to encrypt the contents to secure the data. Click on OK, click on OK again, and notice that these show up in green. Now, the exact same process will apply. If I go and create a file in the encrypted folder, then this file will be encrypted as well. So once again, I'll just choose New, Text Document, and I'll just call this Encrypted, and hit Enter. And I can just double click on it, and I can start entering my text. Okay. Now, I don't see the encryption because, of course, I'm the person who enabled it in the first place. So the encryption is entirely transparent to me. But what this would do would be to protect this file from other users if they were logged into the same computer but using their own account. In other words, if you had a shared computer. Since I created it with my account, I'm the only one who is able to open that file. Now, you might think to yourself, well, I can protect that file using permissions. So as long as I don't give anyone else permission to the file, then they won't be able to access it anyway. That is true, but if another user is an administrator, they actually have the ability to take ownership of other files, so they could access the file. In addition, if this is a laptop and it were to be lost or stolen, anyone who attempted to gain access to that file would not be able to, even if they took the hard drive out and attached it to their own computer and tried to take ownership. the encryption is associated with only my identity, so I'm the only user who is able to access this content. And in fact, since I'm the user who enabled the encryption in the first place, I'm also the only user who can disable it. So if I go back to the parent folder and then right-click and go back to the property window and then click on Advanced, I can simply uncheck the encrypt option, click on OK, click on OK again, and it's going to prompt me to see if I want to apply this change to the folder only or to the folder all subfolders and files. So I'll go ahead and do that since there are files inside of the folder. Click on OK, and that's it. Now the encryption is gone. Similarly, I can remove the compression in the exact same way, just by going to the property window, going to Advanced, and then unchecking the compression option. Clicking on OK, and that's it. Same prompt. Should I apply to this folder only or all subfolders and files? I'll go ahead and do that since there is a file in that folder. Click on OK, and the compression has been removed as well. Okay, so again, it's important to note that these are inherent features of the operating system, and as such, they are really just on-off features. But something else to note is that they are only applicable while the files are on this disk. In other words, if I were to copy those files and paste them onto something like a flash drive, then the compression and/or the encryption would be removed. And the same applies if I were to email you those files as attachments. So both of them apply only to data at rest, so to speak, or while it's on the drive. But if you need to save a little extra space or ensure a little more security for your files, then by all means feel free to use the compression and encryption features. In this presentation, we'll provide an overview of general file management activities, including files, folders, types and extensions, and file permissions. Now, as for files themselves, these are the basic units of storage from our perspective as users that can be stored on any kind of storage medium. And I say from our perspective as users because at the level of something like a hard drive, files are in fact divided up into many smaller units, but that's a physical process carried out internally by the operating system and the file system. So as far as we're concerned, we can't just start writing characters directly to the hard drive. We have to use some kind of application, then enter the information we want, then we have to save that information as a file. Now, there are many different types of files, and each serves its own purpose, but the file types are generally indicative of the software application that was used to create the file in the first place, and/or other compatible applications that can be used to access it. Common examples of user file types include word processing documents, spreadsheet documents, presentation documents, such as the presentation that you're watching right now, image files, audio files, and video files. Now, in many cases, we might not create the files. They might already be on the hard drives of our computers, or we might receive them from other users, but in general, every file is accessible using some kind of application. But there are files on your computer generally referred to as system files, which are not meant to be accessed by standard users, but they can be critical in terms of functionality. So in general, I tend to recommend that if you aren't certain what any given file might be for, then it should really just be left alone, particularly if you're attempting to free up disk space by deleting files. So those different types of files are indicated to the computer by what's known as the file extension, which the operating system will associate with a particular application. Now, most associations are automatic in that when you install something like Microsoft Word onto your computer, it will create a file association automatically, which allows us to simply double-click on the document's icon and it will open using Microsoft Word by default, as opposed to us having to pre-launch Word, then use the File menu to locate the desired document to open it. However, if you encounter or receive a file through email that was created using an application that you don't have, you might have noticed that the file has a rather generic icon, and when you double-click on it, you're prompted to select an application to use to open it. This is because no association exists on your computer for that particular type of file. Now, whether you'll even be able to open the file at all will depend on its type, because many file types can be accessed using several different applications as long as they're compatible. For example, if you receive a file with an extension of PDF, which stands for Portable Document Format, one of the primary applications used to open PDF files is Adobe's Acrobat Reader. So, if you don't have the Acrobat Reader installed, you'll likely be prompted to choose an application for that file type. Now, if you're working on a Windows computer, the Microsoft Edge browser supports PDF files, so you can view it directly in your browser. And in fact, when you're asked to choose the application, there is usually a checkbox that you can enable that says, "Always use this application to open this file type," in which case you can create a file association yourself. So, in short, certain file types are more compatible than others. Some files will only open using their native application, so you might not always be able to open unassociated file types. The extension itself is usually indicated by the 2 or more letters after the period in the file name. For example, employeehandbook.pdf. Many applications, however, are not limited to just a single file type because of exactly the situation just described, whereby any given user might send a document to any other user who might not have the same application installed. So applications are often able to store files in different formats for the sake of compatibility. Some common examples include Microsoft Word, which uses DOC, DOCX, DOCM, DOTX, and DOTM, among others. Microsoft Excel uses Excel, XLS, XLT, XLSX, XLSM, and XLSB, and Microsoft PowerPoint supports PPT, PPTX, PPTM, PPPS, and PPSX. Now, I should point out that in those examples, all types that start with a DO for Word, XL for Excel, and PP for PowerPoint are all still native to those applications. They're just for different types of documents. For example, a DOT file indicates a template versus a free-form document, but those are only a few available types. When you go to save a document in any of those applications, toward the bottom of the Save window, you'll notice a File Type drop-down list, and there will be many more options available, including other compatible applications. For example, if you are using Microsoft Word, and you know that you have to send the file to someone who does not have Word installed, then you can save it as a PDF file, because PDF readers, including Adobe's Acrobat Reader, are free to download for anyone. Image files, audio files, and video files have a very wide variety of extensions, many of which are very compatible with each other because those types of files are often used by just about every user running just about any operating system on just about any type of device. Folders, however, do not have any particular type or any specific application required for their use. Folders simply act as virtual storage containers for our files, just like how you might place a printed document inside a folder in your file cabinet. Folders allow us to organize our data so that we know where to find everything. Folders are also often referred to as directories, but the terms are synonymous. But there are no specific rules whatsoever on how you implement your folders. But whatever structure you use should at least make sense to you so that you aren't constantly having to search for documents because you can't remember where they were stored. Now, folders can be pre-created at any time. In other words, they can be left empty in anticipation of needing them in the future. And any folder can contain another folder, often referred to as nested folders or subfolders. And in theory, a folder hierarchy could go on forever, or at least until you run out of disk space, but in general, the simpler your structure, the better. But it should also accommodate your needs, so if you need to create many levels, that's certainly fine. Again, the main consideration is that the structure makes sense so that you can navigate it effectively. A very common example to many of us might be the Pictures folder. That folder itself acts as the parent directory, but within it, you might create subfolders for each month or each year. Then within those, you might create additional subfolders for each location of the picture or its general topics, such as wedding pictures. Again, the organizational structure is entirely up to you, but by creating a sensible structure, you'll make it much easier on yourself if you have to locate a specific picture in the future. Finally, permissions are the means by which security can be implemented, and while there are different types of permissions for different file systems, they tend to allow or deny the same types of activities. Permissions can be assigned to files directly or to folders, and when assigned to the folder, all permission entries will by default be applied to all files in that folder. So these examples are specific to NTFS, or the New Technology File System on a Windows computer, but they include read, write, list folder contents, modify, read and execute, and full control. Read means that you can view a file, but you cannot make any changes. Write includes read and does allow you to make changes. List folder contents is only applicable to folders as opposed to files because it allows you to see all of the contents of a folder. Without that permission, you would only see files to which you have at least the read permission. All others would be hidden from your view. Modify might sound similar to write, but write applies only to files, whereas modify allows you to create or edit all files in a folder, as well as viewing the properties of a file, such as when it was created. Read and execute, of course, includes the read permission, but also allows you to run executables if, for example, you need to install software from a folder. And full control is entirely unlimited and doesn't restrict any activity. Any user who creates a file or folder on their own, by default, owns that object, and they do have full control. But in networked environments, server-based documents tend to have the full control permission used very sparingly, generally limiting its use to network or security administrators, or maybe departmental heads or managers. Ultimately, file and folder management is an ongoing aspect of computing environments, but if set up in an intuitive manner from the beginning, its day-to-day maintenance is fairly minimal. But if disregarded entirely, file management can become very troublesome, especially with respect to permissions. So be sure to give all file management activities the proper attention. In this demonstration, we'll take a look at the role of services in Windows. And services are essentially just small executable files that run in support of the operating system and the tasks that it needs to perform. Now, for the most part, you do not need to do anything with services, at least not on a day-to-day basis, but they can be configured to a degree depending on your needs. And all services are present by default when you install Windows, but some might be added as you install additional software packages. Now, I'll show you an example of that in just a moment, but in terms of accessing the services, there are a few options, but we can begin by simply right-clicking on the Start button here, and you can then choose Computer Management. Now, in here, there are several consoles available, but over on the left-hand side, you'll see Services and Applications. And if we expand that, we can then select Services. But there is also a dedicated Services console. So let's just close this, and I'm just going to go down to the search bar here, and I'll simply start typing in the word Services, and there it is. The Services app appears, so we can simply click on that, and now I see only services. So it doesn't matter which option you use, the interface is the same. Now, there are a lot of services. If we scroll through the list here, you will see that there are quite a few, and there is a description for each service. And in fact, if you just click on any one of them, over on the left-hand side, you'll see a column that indicates the description. And you'll also notice that services can be stopped or started. Right now, it's giving me an option to start this service because in this case, it has a manual or a triggered start, meaning that it can be launched by something else. But if there is a service that is already running, that is launched automatically, then what I have is an option to stop that service. So they can be started or stopped depending on their current state, but some of them actually can't be stopped. In fact, you'll notice that for this particular example, it says it's a core Windows service that manages local user sessions. So stopping or disabling the service will result in system instability is the final word there, even though it's not displaying in this pop-up, but it is here over on the left-hand side. But if I continue to scroll through the list here, again, there are several services that are running, and let's just choose a different option here, such as performance logs. And this one does allow me to stop the service and or restart the service. Now, I'll give you an example of where restarting is a good option in just a moment. But you can also click on these buttons in the button bar up above. There is a play button, which is to start, then a stop button, which stops it. Pause just pauses it temporarily, and then restart, of course, stops it and starts it again. But as mentioned, the general idea of any service is that it's an executable file that runs in support of the operating system. So a very good example of what that means is, in fact, the service that I was referring to when I said I'd give you a good example of restarting one, and it's called the print spooler service. So we do see that right here. And if we look at the description, it says this service spools print jobs and handles interaction with the printer. So in other words, anytime you click on print in any given application, as far as the application is concerned, that document is already sitting in the tray of the printer. But that's not really what happens. The print job is submitted to the operating system. Windows itself will look after that print job. And this is done because, again, as I just mentioned, as far as the application is concerned, as soon as I click on the print button, the application effectively assumes that the document is already complete and sitting in the tray. But what that means in more practical terms is that I can return to whatever it is that I was doing. And that was actually not the case in earlier applications and operating systems. When you clicked on the print button, the application handled the printing entirely. So while you were waiting for the document to actually be produced, you couldn't do anything else. So by introducing the print spooler service, it's the operating system that takes over the management of those print jobs. So with respect to restarting that service, this can happen if for some reason the printer stalls, or if any kind of processing error occurs and print jobs simply are no longer being processed. You can stop the service, which clears the print queue entirely. Then you can resubmit your print jobs. Now, that's one of the primary differences between stopping and pausing. Pausing would just keep everything in the print queue if, for example, all you had to do was clear a paper jam. But stopping the service empties the queue entirely, so you would have to resubmit all print jobs, but sometimes that's necessary to clear up whatever the problem was. Okay, so that's just one example of a service, and there are clearly far too many to go through here, but I did mention that many of the services are already there by default. In other words, they are inherent components of the operating system. But if I scroll all the way back to the top, in this particular case, what you'll find is an Adobe Acrobat update service. And that's there entirely because I installed the Adobe Acrobat application. If I had not installed that application, of course, the service would not be there. So many applications will create their own services. But again, the idea is to perform some kind of an operation so that I don't have to. This particular example makes sure that the application remains up to date, and it does so automatically. So services run in the background, if you will. They are not applications that you and I use on a daily basis. They simply run in support of the general activities of the operating system. And I'll give you one final example. I'm going to scroll down a little bit to what's known as the DHCP client service. And this tells us in the description that it registers and updates IP addresses and DNS records for this computer. If the service is stopped, the computer will not receive dynamic IP addresses and DNS updates. So this is something that happens every time your computer boots. When it boots up, it needs an IP address. So rather than us having to manually supply one, it can request an IP address from a DHCP server. That stands for Dynamic Host Configuration Protocol. And the server responds with an address for us. It then also informs a DNS server, which is Domain Name System, that it just received this IP address and that this is the name of that client computer so that it can equate the IP address to a name. So if that service is stopped, you don't get any IP address updates, nor will you inform the DNS server of those updates, and you may very well not be able to communicate on the network. So clearly this is a very important aspect of our day-to-day operations, but we don't ever have to do anything. It's the service that does all of this for us. So again, services are individual executable applications that basically support the day-to-day operations of your computer. So for the most part, you'll probably only interact with these when you're troubleshooting a system. If something seems to not be working, it's a good idea to check to see if there's a service that supports that activity and then determine its status. And if for some reason it seems to have stopped or failed, you can try restarting that service to see if that clears up the problem. In this demonstration, we'll outline the role and features of Windows processes. And these are similar to services, which we just talked about in our previous video, but there are a few distinctions. But before we get to that, in terms of accessing processes, you can do so using the Task Manager utility. And that in itself can be accessed by right-clicking on the Start button in Windows 11 anyway, and choosing Task Manager. In Windows 10, you can right-click anywhere on the taskbar and choose Task Manager, but in Windows 11, you do have to click directly on the Start button. Now, when the Task Manager first appears, you might see it in this Fewer Details view, which only shows the applications that you have launched yourself. So I intentionally launched the Calendar, the Microsoft Store, and Photos. So they will show up if you are in this Fewer Details view, but if you then click on More Details, you'll not only see the applications that are running, but these background processes. Now that, in fact, brings me to the difference between processes and services. Processes, for starters, include the software applications that you launch. So I am seeing my applications, but then I see a number of background processes here that are doing exactly as their name indicates. They're running in the background. So I really don't have to interact with these at all. And they generally support the activities of Windows itself. Now, that in itself does sound similar to a service, but process is something that launches and runs for a specific purpose and then shuts down whenever that particular purpose has been satisfied. In fact, you might notice that a process is appearing and disappearing here based on whatever it is actually doing. So if I just scroll back up toward the top, it does give you a total number of background processes. And in fact, when I first opened this window, it said 38. Now it just changed to 36. Now it's up to 37. That typically does not happen with services. A service will launch as soon as the computer starts in most cases. Those are automatic services, although there are some that must be started manually or those that can be triggered by another service. But once a service starts, it will remain running until you shut the system down or until you manually stop the service. So basically, processes can come and go. Services, once started, will remain started. Okay? So that's the primary difference. But from the perspective of what you and I do every day, you can manage processes using the Task Manager. Now, the most notable operation that you can do from here is to shut the process down. Now, you might think to yourself, well, why do I need to use Task Manager for that? I can just close the application. And you're absolutely correct. So if, for example, I bring up my calendar, I can absolutely just close it, and that's it. And we'll see the process disappear from here in just a moment. And there it goes. Okay, so clearly you can shut down your processes. But sometimes an application freezes, in which case its entire interface becomes unresponsive. So you can't shut it down, but you can from the Task Manager. So if I right-click on the process, there is an option here to end the task. Okay, so in fact, I'll pull up the Photos application here, and I'll leave that visible, so to speak. So let me just move the Task Manager over a little bit here. I'll right-click on the Photos process, and I'll choose End Task, and there it goes. Okay. Now, you might also notice a little number in brackets next to some processes, and that just indicates that there is effectively more than one running in the background in support of that application. In this case, for the Microsoft Store, there are 2 sub-processes, but if I choose End Task, both of them will end. Now, you can do that with background processes, but it typically is not recommended unless you see something wrong with it. Now, how do you know if there's something wrong? Well, that's where these values come into play over in the columns on the right. The CPU percentage, the memory percentage, the disk percentage, and the network percentage indicate how demanding that process is on your system. So if, for example, you see a process that seems to have the processor or the CPU locked at a very high value, then it means something has gone wrong with that process, and you can right-click and choose to end that task. Now, many of the processes aren't critical, but some of them might cause instability with the system or even require you to reboot. But that would not cause any permanent damage. You might just have to reboot your system. But generally, you leave the background processes alone because, as we mentioned, they start and stop on their own whenever they're required. But if you do see any given process that just seems to be consuming far too many resources, then you can end that process and, if necessary, maybe reboot your system. But ideally, if you can stop just the failed process, then of course you don't have to reboot. You might need to launch something again, but generally that can save you a bit of time and possibly prevent the loss of any work that has not been saved. But in general, Task Manager is the utility to view and manage your processes, and it can be particularly useful when troubleshooting to determine if there are any processes that are experiencing any problems. In this presentation, we'll examine the purpose and features of device drivers, which are software components that allow the operating system and a particular device to communicate with each other. And a good way to think about them is, in fact, by the name driver. In that, if you think about something like a car, on its own, it's just a collection of hardware. It just sits there doing nothing until a driver gets in and controls its operation. In other words, without a driver, the hardware wouldn't do anything. Now, while all drivers provide similar functionality in that they instruct the operating system as to how to interact with a device, drivers are hardware dependent and specific to the operating system into which they're being installed. For example, if you purchase a new printer, it will typically indicate the operating system or platforms with which it can be used. And if you're looking to download drivers from the manufacturer's website, you have to ensure that you select the driver for the appropriate operating system and platform. In terms of the communication pathway, drivers sit between the physical device itself and the operating system. But of course, we as users will most often rely on a software application. But with this separation comes independence with respect to the applications and the device, meaning that once a driver is installed and the operating system knows how to communicate with that device, then all applications can use that device provided it offers the functionality they require. In simpler terms, once something like a printer driver is installed and the physical device is connected, every application on your computer that has a print function can now print, because applications don't communicate directly with the printer. They only communicate with the operating system. If they did, then a different driver would likely be required for every application on your computer. Now, just about every piece of hardware on a computer needs some kind of instruction set in order to function properly, but as far as drivers are concerned, they typically are only required for what we tend to think of as peripheral devices or extra components beyond those that are required for basic functionality. In other words, components such as the processor, memory, and hard drives do require instructions, but they're lower level devices that have their instructions embedded within the BIOS or the UEFI of your system. So we don't ever have to install drivers for those devices. So it's typically the devices we use to expand the functionality of our systems that require drivers. Now, that said, there are several devices that can also use generic drivers that are built into the operating system that will provide basic functionality, but they likely won't provide the full feature set of the actual device driver. For example, something like a mouse requires very little instruction in terms of functionality, but if you purchase an advanced gaming mouse with many additional buttons, if you simply plug it into the computer, it will most likely work as a pointing device. In other words, you'll be able to move the pointer around the screen, but it would be unlikely that all of the extra buttons would work for your games. So, that said, common devices that require drivers include network interface cards, graphics cards, sound cards, monitors, printers, scanners, and many others. But again, the general distinction here is that none of these devices would be required for the computer to simply boot up and function. Now, you might think that if you didn't have something like a monitor, then you wouldn't really be able to do anything, but a missing monitor would actually not prevent the computer from booting successfully. We just couldn't interact with it. So, in general, drivers are required for those devices that expand or enhance the functionality of our systems. Now, I'd like to come back to the point about generic drivers for just a moment. They can sometimes be used because some devices are designed according to a published hardware standard, in which case the drivers can be written by anyone, not just the specific manufacturer. Common examples of devices that often use generic drivers include mice, keyboards, and monitors. In fact, on my system right now, I'm using a laptop with a secondary monitor that is a proprietary model. But if I look in my device manager at the driver for my monitor, it simply lists generic plug-and-play monitor. Likewise, I have a proprietary wireless mouse and keyboard, but for each of those, it just lists HID compliant mouse and HID keyboard device, where HID stands for Human Interface Device. Now, there is a specific software and driver set available for my monitor, which does provide some additional configuration options, but I simply don't use them. All I'm concerned with is functionality, and virtually every monitor is designed to a published hardware standard. So it's very likely that any monitor you attach to your computer will function with a generic driver. So when it comes to obtaining drivers for your devices, it will depend on the device, but just about every device manufacturer will of course provide the appropriate software and driver set with the device itself, perhaps on a CD or a DVD, or they'll provide you with a link to download the driver from their website. I generally tend to recommend the download option because, like all other software, drivers are also updated. So if you do purchase a device off the shelf, it may have been sitting on that shelf for months. So even if a driver was provided, it's possible that it's already out of date. Now, it will still work, but by downloading the driver from the manufacturer's website, you can ensure that you always get the latest version. But for many devices, you might not need to do anything at all in terms of installing and configuring that device because of a feature known as plug and play. Now, this process has actually been around for a very long time, and it basically means that drivers for many known devices are already included with your operating system. As a common example, on systems running 64-bit versions of Windows, Microsoft requires that the device drivers for any device be what's known as signed, which in essence means that they've been verified by Microsoft as being stable and reliable. Or in the case of generic drivers, Microsoft may have created their own drivers themselves, because as mentioned, anyone can create a driver for a device that is manufactured to a published standard. So, in the case of signed drivers, or those created by Microsoft, Windows maintains a repository of drivers for those devices. So, if you physically install a device that has a signed or a Microsoft-provided driver, and the operating system detects that device, it will typically install the driver automatically. Now, while plug and play is great when it works, it doesn't always work. Even though a driver might be signed, it doesn't necessarily mean that it's included with the operating system. So depending on the device, there may still be some instances when a manual installation is required. But these days, even that is usually a fairly simple process. Typically, it just involves running an installation program first to add the driver, then physically installing the device. Since the installation program has already added the driver, Plug and Play should now detect the device automatically. So if you aren't certain of the sequence, in general, install the software first, then attach, connect, or otherwise install the actual device, and again, Plug and Play should detect it. Ultimately, the drivers you add, or even simply use, will depend on the devices already present on your system and or those you want to add, but without drivers, our computers would have rather limited functionality. In this demonstration, we'll take a look at scheduling tasks in Windows, which perhaps not surprisingly uses a utility known as the Task Scheduler. Now, I've already created one and I have a very simple script to use as an example, but I will go through all of the steps and show you exactly what I did. But for starters, the script itself is just a very simple message box. If I double click on it here, we see that it just says, "Good morning, Aaron," and tells me to have a great day. So that, of course, is perfectly fine, but the task itself really can be just about anything in terms of running a program or a script. And you can even have it send an email, although that is being deprecated, but we'll see that in just a moment. So again, in this case, the script, of course, is meaningless, but the task can be just about anything. Now, the application itself can be accessed by simply going to your search bar or your start button and just start typing in Task Scheduler, and you will see it appear. So simply launch that. And don't be surprised if you do see some tasks already present in the Task Scheduler library, because there are several there by default created by Microsoft and or other applications when they were installed. So for example, the first two entries here were created automatically when I installed Adobe Acrobat and this particular printer. The Microsoft Edge tasks were created by Windows itself when I installed it in the first place, and the same goes for OneDrive. So again, don't be too surprised if you see some default tasks, but to create your own, you can simply right-click on Task Scheduler Library, and to get started, the easiest method is to choose Create Basic Task, and that is exactly what I did. So from this point, you just go through a wizard and it prompts you for specific values. So the name can be whatever you like. In my case, I just called it Run Script, but you can call it anything you like, and you can give it a more detailed description if you want. Then click on Next. As for the trigger, you can specify daily, weekly, monthly, one time, when the computer starts, when I log on, or when a specific event is logged. So clearly that's up to you. I went with the daily option. Let's click on Next. Then you can specify when it should start and at what time this should happen. So I left the date at its default, but I did set the time to 8 a.m., basically so that it would run first thing every morning. And as far as the recurrence goes, I also left it at the default of 1 day, meaning of course that it will run every day. But in fact, you could choose 2 or 3, then it would run every second day, every third day, or really any value that you like. So again, I won't bother changing anything there in this case. Let's just click on Next. So these are the options I mentioned. You can start a program, which does include scripts. You can send an email, or you can just display a message, but take note that both of those are listed as deprecated. Now, that means that it is still an option. In other words, it is still supported, but expect to see it disappear in the next version, perhaps, or possibly even with future updates for this particular version. So I just left it at Start a Program. And once again, we can click on Next. So then it asks us, well, where is the program or the script? So there is my script directly on the desktop. I just clicked on the Browse button. I went to the desktop, selected my script, clicked on Open. This particular script does not need any arguments or any other values, so I just clicked on Next, and that's it. The summary page allows you to verify some of the basic details, but from that point you can just click on Finish. Now, since I have already done that, I'll just click on Cancel, but there is my task right there. And it does tell me that it's ready and it's going to run at 8 a.m. every day. Now, I can test this by simply right-clicking and choosing Run. Now, it will appear here. It's just in the background, but if I just click down below, there it is. Okay? So that verifies that the task will run. And if I right-click again, notice that I can end the task if it is something that takes a long time. I can disable it entirely. I can export this and send it to someone else, or I can view its properties and or delete it at any time as well. So it's really up to you, of course, but it depends on what you need out of your system. A common example of a regularly scheduled task might be to upload files at a certain time of day or to gather up log files for review. Again, the task itself can be just about anything as long as it can be either a program that can be executed or a script, or as we have seen, you can send an email, at least for the time being, or just display a message. So again, the task is up to you, but the scheduler allows you to ensure that it can be run at a regular interval with no manual intervention required. In this video, we'll compare and contrast command line interfaces, or CLIs, and graphical user interfaces, or what is commonly referred to as the GUI. Now, ultimately, both interfaces provide us with the means to interact with the computer, and for most of us, the GUI is the most familiar interface, and while the CLI might seem difficult or even intimidating to some users, if you're planning on a career in IT support or administration, then it is strongly recommended to become familiar with CLIs. So, why do I say that? Well, for starters, let's take a look at some of the characteristics of a command line interface, beginning with the fact that the operating system is accessed by way of typing in commands, which, by the way, is why I say that some users might find the CLI environment intimidating, because you have to know the specific commands that are available to be used, and they require specific syntax, including the use of parameters and arguments to ensure that the task at hand is executed correctly. But once you have learned some of those commands, in many cases you can complete operations much more effectively and efficiently by using a CLI as compared to a GUI. Now, there are many examples of that, but a common one would be running scripts that can perform many tasks in an automated manner, or they can perform very repetitive tasks that would otherwise take a very long time through a GUI. As a practical example, if a new employee is hired by an organization, generally many operations must be performed to get that user up and running. They'll need a user account that will very likely have to be assigned to any number of groups. A mailbox will have to be created, possibly an account in the corporate database. An HR record might need to be generated, possibly a cloud-based account for accessing online services, and any number of other tasks, all of which can certainly be done through graphic user interfaces, but each one would have to be done separately. But with a CLI, a script could be created that can do all of that with a single execution of the script that might literally take seconds to launch. Now, again, that's only one example, but another very useful application of CLIs is when troubleshooting. In many cases, there just aren't appropriate GUIs to find out the information you need. For example, on a Windows computer, if you're experiencing network connectivity issues, such as connecting to a print server, and you want to see a cache of the names of other systems to which you have successfully connected, there is no GUI that can provide that information, but the command line can. The CLIs available in common operating systems include the command prompt and PowerShell in Windows, SH, which is short for shell, Bash, C Shell, Korn, and Z Shell in Linux, and Terminal on macOS. Now, each of those will have their own specific sets of commands, and they all use different syntax and different formats, but the overall environment is largely consistent in all of them, in that in all cases you're typing in commands to complete the desired operations. By contrast, the graphical user interface provides us with the ability to interact with the operating system by using input devices such as a mouse and the use of graphical objects such as icons, buttons, and menus to carry out our operations. GUIs are often far more intuitive to most users, and they require less specialized knowledge than CLIs. So for most of us, this is the environment of choice. And when it comes to using the standard applications that we use on a daily basis, such as browsers, email, and line of business applications, there just isn't any option to run those types of applications in a command line environment. Nor would you even want to, even if we could. Imagine trying to do your online banking by typing in a bunch of commands. It just wouldn't be practical. Common operating systems with GUIs include Microsoft Windows, Mac OS, and Linux, and of course almost every mobile OS in use these days, such as iOS and Android. And again, for mobile devices such as phones and tablets, working in a CLI would be exceedingly difficult due to the limited screen size. So, looking at each in terms of pros and cons, beyond what was mentioned already, benefits of CLIs include very fast performance. Processing graphic information is one of the more demanding tasks of any computer, so if you had a system that only provided a CLI, it would in fact offer very fast performance for what it could do, and it could also do so with far less memory. Now, you typically don't see too many desktop computers with only a CLI, but it is actually quite common in the server world. Most servers are managed using remote tools anyway. In other words, as an administrator, I can just use graphic interfaces on my own local desktop computer to connect to the server remotely and perform my tasks that way. Therefore, the server does not need those interfaces to be installed. Windows Server, in fact, offers an edition known as Core, whereby there is no graphic interface at all, allowing it to dedicate its resources to other more important services. In addition, because they're just text-based environments, they can run on very low-cost, low-resolution monitors and graphics cards. So those servers do not need expensive video equipment. And it's also worth reiterating that command line tasks can be done in a scripted or automated manner, and they can execute very rapidly. Drawbacks include having to learn the commands along with their syntax, parameters, and proper use. And in most cases, there is also no undo option for commands that have been executed. Many of us are likely very familiar with the undo button in many applications. But once a command has been executed, the only way to undo it would be to issue another command that possibly resets what you just did or reconfigures something back to its original state. Although it should be noted that certain commands can be stopped or interrupted during execution using certain keystrokes, but that will often only stop whatever is happening and not necessarily undo what has already been done. And also worth reiterating, CLIs can also just be intimidating. New users especially are often quite wary of CLIs since there is no real information available from within the interface itself as to how to even get started. As for the GUI, benefits include an intuitive interface that is much easier to learn and use, whereas a new user might not have any idea as to how to get started with a CLI. That same user with a GUI will very likely be able to navigate and start using applications right away, even if they aren't familiar with the specifics of any given application. And for as high-performing and functional as a CLI can be, one thing they lack is the ability to multitask. You can certainly execute scripts that can complete tasks very quickly, but while that script is executing, you can't execute another one. Every command or every script must be executed one at a time, whereas in a GUI, you can have many applications all running at the same time. GUIs are also simply much more engaging for the user. CLIs are usually little more than monochrome environments with nothing but text, whereas GUIs offer high-level graphics and sleek designs, making them far more inviting to the user. However, while they're much easier for us as users to work with, that is not the case for those who develop them. They take far more time and effort to create, and as mentioned, they require far more in terms of system resources to run, so their development and implementation is far more complex, And similar to how there are a lot of commands to learn in a CLI, there can still be many different interfaces to learn in a GUI, at least for those who work in technical support. For example, on a Windows system, there are many separate and distinct interfaces for managing various aspects of the system, so there is still a learning curve with GUIs. But with all of that said, perhaps the best feature overall is that most computers offer both, so we don't have to choose one over the other. And even technical users will make use of both because, quite simply, certain tasks are better suited to one or the other. So at the end of the day, in most situations, we can work in whichever environment we prefer. In this video, we'll take a look at using the Windows command prompt, which is a utility that allows you to interact with the operating system effectively using text-based commands. Now, you might wonder why this is necessary, and in most cases it isn't, because of course there are graphic interfaces that we can use, but the command prompt has been around in Windows for a very long time, and in fact, the command prompt really goes all the way back to the days of Microsoft DOS, or Disk Operating System, when the command prompt was all there was. In other words, there was no graphic interface. So again, we do have very convenient interfaces these days, but there are a lot of instances where it might just be faster and or easier to use the command prompt. Now, there are a tremendous number of commands that can be issued, so we clearly cannot go through them all, but I will give you a general idea as to some of the operations that can be performed by using the command prompt. Now, for starters, in terms of simply loading it, you can just go to your Start button, and then just click on that and begin typing in the word command, and you should find the command prompt come up as an option, so we can just dismiss that. And when it does load, it will by default launch in your own user profile folder. The local administrative account on this particular system is under the name of a user known as Max Bishop, so that's why you're seeing M Bishop in the prompt there, inside of the users folder. Now, you can change to different folders if you want to, and in fact, we'll see that in a little bit. But let's get started with some basic commands, and one of which is very common. If you need to determine your IP address for troubleshooting purposes, you can simply type in ipconfig, all one word, or ipconfig, and then simply hit enter. We see our address in both version 6 and version 4 of TCP/IP. Plus, we see a subnet mask and a default gateway, which is the router that provides you with access to the internet. Now, all commands in the command prompt also support what's known as arguments or parameters, sometimes called switches. But another nice feature of the command prompt is that it remembers previously issued commands, and you can access them and cycle through them using your up and down arrow keys. Now, since I've only entered one, my up arrow key will retrieve the last command that was issued. So I'll just press the up arrow key, and there it is. But if I had entered several commands, I could just use the up and down arrow keys to search through them. So that just saves a little bit of time. Then I can hit the space, type in a /, which is the separator for a parameter, and I'll type in the word all, and if I hit enter now, I see much more detailed information, including when I got my IP address from a DHCP server and how long it's valid for. In other words, when it's going to be renewed. So again, I see a lot more information, and I can scroll through the results here. And in fact, here's another command. Notice that it tells me the host name in this case, which is Win11CL4 for Windows 11 Client 4. But if I needed to know that name and I wasn't exactly certain of the syntax, then I can also type in the command host name, all one word, and I see just the name of my computer, Win11CL4, down at the bottom there. So those are just some informational commands, if you will, but I can also work with my system. For example, if I need to start or stop services, I can do that from the command prompt. Now, we talked about services in an earlier video, and there is a graphic services console. But if, for example, I'm already in the command prompt and I'm working on something like a print server, and users are informing me that print jobs are not being produced, then a good quick fix option, if you will, is to try stopping and starting the service again. So for that, I can type in net stop, then the name of the service. Now, if you aren't certain of the name, you can go to the services console, and of course you can stop and start them from there as well. But if you just double click on the service, it gives you the specific name that you can use in commands in the property window. In this case, the name of the service is called spooler. So all I have to do is type in net stop spooler and hit enter. It shows me that the service is stopping. Then I can just type in net start spooler, and of course it will start again. So as mentioned, if I was already in the command prompt and users are telling me that the server is not printing anymore, then I can stop and start that service in a matter of seconds, as opposed to closing this interface, then launching the services interface, then finding the service, then clicking on it, then stopping and starting it. Now, granted, that doesn't take all that much time, but you just saw how quickly and easily I could do it from the command prompt. Now, you can also perform some maintenance. If, for example, you opened a file and you received some kind of error, there could be a problem with the file system or just the file itself or even the disk. And there is a utility called check disk, which is CHKDSK, that you can run to quite literally check the disk. So I'll just hit enter here. And this is going to scan the disk looking for problems. And if there are any that can be repaired, you can also issue in a parameter that instructs it to repair that. And I'll show you how to find out what the parameters are in just a moment. But basically, this is just going to tell me if there are any problems. And in my case, it says Windows has scanned the file system and found no problems, so no further action is required. But if you did need to repair them, once again, I'll just hit my up arrow key. There's check disk. And I can type in the /, and if I'm not certain of the parameters that are supported, I can type in a question mark, which will tell me. So there are all of the supported parameters. So if I wanted to repair the problem as well as just find out about them, if I scroll back a little bit, it tells me that the /R locates bad sectors and recovers any readable information. So there are a number of arguments or parameters that are supported with just about every command. And if you aren't certain as to what they are, the /? will always tell you. Finally, you can also perform some basic file management here. So if I want to create some folders, for example, I can do so. Now, currently, I'm in my user profile folder. So just to make things a little bit easier, I'm going to switch to the root of the C drive, which is CD for change directory. Then if I just type in a \, that stands for the root of the drive. So I'll hit enter and notice that I'm now directly on the root of the C drive. Here's another command, by the way, to clear the screen. CLS removes everything from the screen. It literally stands for clear screen. So to make a folder now, I can issue MD for make directory, and I'll just type in test for a test folder and hit enter. Now I can see that folder if I go to the File Explorer utility. Then we can go to the C drive, and sure enough, there is the test folder. Now you can create a folder with a space in the name if you want to. But if that's the case, you need to enclose the name in quotation marks, okay? But we'll just go with test here. And then if I want to change into that folder, I can type in cd test. Now I'm in the test folder. So if I make another directory in here, we'll just call it subfolder and hit enter. Then if I now type in dir, which stands for directory listing, I'll see that this test folder contains a subfolder. And if we go back into the Explorer, we'll see that subfolder inside of test. Okay? And I can keep doing that as much as I want to, but let's go back into the command prompt here. And now we'll type in RD to remove a directory, and we'll remove the subfolder and hit enter. And once again, if we go back into the File Explorer, we should see that it has been removed. Okay, so again, many basic file management tasks can also be performed from the command prompt. So, as mentioned, there are a tremendous number of commands that can be issued, and it will take some time to get familiar with them. But in general, the command prompt can be very useful for configuring your system or just performing some basic maintenance or doing some general troubleshooting. But all of those options are available from within this single interface, so it is a lot more functional than what people might think. And to finish off, once you are finished with the command prompt, you certainly can just click on the X in the upper right-hand corner, but you can also just type in the word exit and hit enter, and that will close the application as well. So again, if you prefer to use graphic interfaces, there's certainly nothing wrong with that, but don't discount the functionality and the convenience of the command prompt. In this video, we'll take a look at the basic usage of Windows PowerShell, which is another command line environment, although it is far more powerful than any previous command line environments, most notably the command prompt. Now, PowerShell was released quite some time ago, and while standard users will probably not use PowerShell very often, it is an excellent tool for performing administrative tasks. So if you are intending to pursue a career in IT support or administration, then you would do very well to take some time to learn PowerShell. And I do want to stress that statement. It will take some time. PowerShell really can be thought of as a programming language, but it still has some basic characteristics that we can cover in this demonstration here. So I'm using what's known as the PowerShell ISE, which is the integrated scripting environment, simply because it provides you with this scripting pane. So that's this white section here where I can type in several commands and I don't have to execute them just yet. So this allows you to create a script without having to execute anything. And the pound sign or the number sign here can be used as what's known as a comment symbol, meaning that you can type anything after that and it won't process. So it allows you to describe the command that you just entered. And you might also notice that it's color-coded. The blue text is the base command. Then the purple text, such as we see here where it says get service, is an object of that command. And there are also parameters which are used to refine a command, and that's this darker blue text here. Then, of course, the comments show up in green. Now, one thing that is consistent with all PowerShell commands is the format of the base command itself. And in this first example that I have that says get command, what's a little bit different about the format in PowerShell is that every command uses this two-word format with a dash in between, and the first word is always a verb, and the second is always a noun. So that's one thing that you can always rely on. Every single PowerShell command, and I should also mention that the official term is actually commandlet, which is a contraction of command and applet. So that's what I have here in parentheses. But anyway, every single PowerShell command always uses this verb-noun syntax, and there are no spaces between them. So the first command is to get a list of all supported PowerShell commands. Now, I say supported because the list of commands that you can execute will depend on the system and what is installed on that system and what applications and services are running. But in any case, you can still retrieve a list of commands. Now, this list is very extensive, and as mentioned, it will take some time to learn PowerShell. But if we look down in the very bottom right-hand corner, it tells us that we are currently on line 1. Okay, so I'm going to highlight this command, and with it highlighted, I can right-click on it and choose Run Selection, and it will bring back the results. And now look at the line number, 1733. Each commandlet is on a single line, so clearly we received a very comprehensive list of commands, okay? So I'm not trying to overwhelm you with any of the commands. I'm just pointing out that it will take a bit of time to learn the commands, and it's fair to say that there would be very few people, if any, that fully know every command. You tend to focus in on certain areas if you are going to become proficient at PowerShell, but again, this just gives you an idea as to how thorough PowerShell is. Now, for any given command, if you do want to find out more, you can use the get help command. Then you can specify a particular command. So the get service command here is a command that I might be interested in. So if I want to find out more about that command, I can issue get help about get service. Then the parameter of examples will actually include some real examples to give me a better idea as to what that command should look like. So let's highlight all of this, and we'll right click and choose Run Selection. And we can scroll back up, and we do see that there are several examples here. So in fact, it's showing me example 11 at the bottom. So quite a few examples were returned. So it's giving me several, and it tells you more about the command itself. So you can read through that to find out what this command is all about and see the examples. So it tells me the synopsis gets the services on a local or a remote computer. Then I start seeing the examples, and the very first one is quite basic. It is simply the get service command. Okay, and in fact, that is what I have as the very next command. That will retrieve a list of all services running on this computer. So let's right click and we'll run this selection, and there they are. Okay, so this is the exact same list that you would see if you were looking at the services console. And we did see that in an earlier demonstration. It's just a text-based list. Now, another interesting feature of PowerShell is that it supports all command prompt commands as well. So that's the final entry I have here, which is ipconfig. And that is something that you can execute in the standard command prompt environment. But PowerShell supports all of those commands as well. So I can right-click here, and I can run that selection, and I see the exact same information as I would if I were to execute that in a command prompt. So again, all command prompt commands are supported in PowerShell. Now, I have one final example, which is a lot more advanced in terms of the syntax, and I don't want you to get caught up on the syntax, but I do want to show it to you because it highlights a very useful feature of PowerShell. And for starters, I should also show you that you can clear all the results down below here by clicking this little squeegee button, which clears everything out. Okay. Now, I have everything over on a separate tab here. And again, the syntax is a little more complex, but I'll still go through everything. But I will tell you that this command is simply retrieving a list of services that are currently stopped and have a start type of manual. Now, that in and of itself would actually still retrieve a fairly lengthy list of services, so I'm adding an extra filter to simply pare down the list a little bit more. So I'm also looking for services that have a name that starts with APP. Okay, now that's basically what I'm doing. And I'm going to go ahead and just execute this just to show you the results. Okay, there are my services. Now I'll go through this command in a little more detail. So for starters, we are getting all services. If I were to execute just that portion, it would be no different than what I got the first time. That's fine. But what you'll notice is this vertical line here, which is referred to as the pipe character. This means that you can take the results of the first command and essentially send them into another command. And the entire result set is treated as a single object. So I'm taking all results, I'm examining them, and I'm filtering them down based on certain characteristics of each entry. So again, the idea of piping is simply the fact that you can string commands together. So from the first command, I pipe those results into another command, then everything here inside the curly braces is acting as the filter. Now, the $sign and the underscore are simply acting as placeholders for each value that comes back so that it can be examined with respect to its status, its start type, and its name. And in each case, I'm looking for values that are equal to stopped for the status and equal to manual for the start type. And as for the name, it uses a different argument, in this case, like, because I'm using a wildcard character. So what I'm looking for are those that start with APP, then the asterisk is the wildcard, meaning any set of characters after that. So I see results that start with APP. And again, that was just to filter down the number of results that came back, just so I got a smaller result set. But we're not finished yet. What I see here is a list of services, but as far as PowerShell is concerned, that list can be treated as a single result set or a collection, so I can manipulate the entire set by issuing a single command. So if I feel like these services that are currently stopped should be started, I do not have to start each one separately. I can just go to the end of my command, and I can type in another pipe character, and I can add in start service. That's it. This will now act on the entire result set, and it will start all of those services. Let's go ahead and execute, and I should see those services all get started. Now let's verify that. So we see the application identity, information and management services, then another one called app readiness. So I have my services console already up and running. Let's switch over to it, and we should see our app readiness service is running, our application identity service is running, the app information service is running, and the application management was the last one, and it is also running. So again, all of those services were started with a single command once I retrieved the values that I was interested in. So this again is where PowerShell really shines, so to speak. Extrapolate this to any given command that might return 100 results or 1,000 results. Then if you need to perform any given operation against all of those results, you can do so with a single command. So that can be a very powerful feature of PowerShell. So if you intend to pursue a career as a support technician or an administrator or even a developer, I certainly recommend that you invest some time into learning PowerShell. So in this course, we've examined basic concepts surrounding computer operating systems. We did this by exploring application hardware, Windows management and managing applications and devices, user management and access control, file systems, key operating system features, and using file and folder encryption and compression, file management activities, Windows services and processes, drivers and scheduling tasks, command line interfaces versus graphic user interfaces, the Windows command prompt, and PowerShell. In our next course, we'll move on to explore basic concepts surrounding computer software and web browsers.